Our solar system is more than just the 8 familiar planets orbiting the Sun. Beyond Neptune lies a vast, mysterious realm where the Sun is just a bright star in the darkness. This is the Kuiper Belt, a ring of icy bodies, including Pluto, and relics from the solar system's birth. Further still is the scattered disk, and then the Oort cloud, a theoretical shell of comets enveloping our system. Here, objects drift so far from the Sun that passing stars can send them on epic journeys or eject them forever. This is the great unseen frontier, so empty that finding anything is like searching for a grain of sand on all the world's beaches. The few objects we detect are faint, slow, and distant, ghosts in the cosmic dark, their presence revealed only by subtle gravitational tugs. Yet these distant wanderers are time capsules, preserving the conditions of the early solar system. For astronomers, this dark expanse is both a challenge and an opportunity, a puzzle box on a cosmic scale. Why are some of these distant orbits so strangely aligned? What forces shaped this architecture? The answers could reveal the story of our solar system's birth and the chaotic processes that shaped our world. Every new discovery out here is a vital clue in the grand detective story of creation. To explore this cosmic ocean, astronomers need powerful tools. Enter the Subaru telescope atop Mauna Kea, Hawaii, an 8-meter marvel peering deep into the night. Here, the fossil project began, a global team determined to map the unknown outer solar system. Their mission? Find the most distant, unusual objects, cosmic fossils from the dawn of time. The search is painstaking. Subaru captures vast images and software hunts for tiny points of light that move ever so slightly. Most stars and galaxies remain still, but the computer flags the rare outliers. Each candidate is scrutinized, its path tracked to rule out glitches or known objects. It's a search for a moving needle in a cosmic haystack. Over years, Fossil cataloged dozens of new trans-Neptunian objects, refining our map of the outer solar system. But the team was after something truly extraordinary. A fossil that could unlock the next chapter of our cosmic story. They just had to keep looking. The breakthrough came in late 2023, a faint, slow-moving point of light flagged by the Fossil team's software. It was so dim and sluggish that it nearly escaped detection. A young astronomer dug through archived images, tracing its barely there path across months and years. The preliminary orbit was astonishing, vast, tilted, and detached from Neptune's influence. This was no ordinary trans-Neptunian object, it was a cosmic hermit. Excitement spread across the global team as they scrambled for telescope time to confirm the orbit. Each new observation refined the calculations. This object didn't belong to the Kuiper Belt or scattered disk. It was a true outlier, a resident of the deep. The team named it Ammonite, after the spiral fossils that reveal Earth's ancient past. The name was perfect, a window into the solar system's own deep history. Ammonite was not just another discovery, it was a new class of citizen in our solar system. Its existence challenged everything we thought we knew about the outer solar system. The hunt for its secrets had just begun. Ammonite belongs to a rare group called Sednoids, named after Sedna, discovered in 2003. Only a handful are known, defined by orbits that never come close to Neptune, dynamically detached from the giant planets. Ammonite's orbit is extreme at its closest. It's over 70 times farther from the Sun than Earth, and at its farthest nearly 1,000 times. Light from the Sun takes over 5 days to reach it at aphelion. Ammonite is likely a dwarf planet, about 800 kilometers across, smaller than Pluto, but larger than many Kuiper Belt objects. Its surface, frozen and dark, is probably coated in complex organic molecules formed over billions of years. What sets Ammonite apart is its profound detachment. Unlike Pluto, it feels no pull from Neptune. This raises a monumental question: if Neptune didn't put it there, what did? Its existence breaks our simple models of the outer solar system. Ammonite is a clue to a hidden history, a missing piece that forced this world onto its lonely path. It's not just a discovery, it's an anomaly demanding explanation. The search for answers would reshape our understanding of the solar system's edge. Ammonite's orbit is a cosmic riddle. Ammonite's orbit is a story written in gravity, a record stretching back billions of years. Unlike most solar system objects, constantly jostled by planets, Ammonite's path is stable and immense. 1 year on Ammonite lasts about 12,000 Earth years. The last time it was here, humans were in the Stone Age. Its orbit is highly elliptical, a stretched loop, not a gentle circle. Such eccentricity hints at a dramatic event in the past, a powerful gravitational kick. Ammonite's orbit is stable over eons, insulated from Neptune's chaos. The path we see today is essentially unchanged since the solar system's youth. It's a pristine relic, frozen in time. Studying Ammonite is like reading a fossilized record of the early solar system. Its orbit preserves the signature of ancient forces, long vanished. This makes Ammonite not just distant, but a messenger from a bygone era. Its journey through time is a window into the solar system's forgotten past. Ammonite is a cosmic time capsule. The name Ammonite captures the essence of this discovery. On Earth, ammonites are spiral fossils, windows into ancient environments. Ammonite, the celestial body, is a cosmic fossil. Its composition preserves the raw material of planet formation. Far from the sun's heat, its chemistry is unaltered, a sample from the dawn of the solar system. More than that, its orbit is a dynamical fossil, a preserved relic of the early solar system's chaos. Ammonite's peculiar path couldn't have formed in today's orderly system. It was sculpted by ancient violent events. By studying its orbit, astronomers can infer the existence of lost planets or passing stars. Ammonite is a signpost pointing back to a different solar system, a clue to our origins. Its story helps us reconstruct the dramatic birth and evolution of our cosmic home. Ammonite's discovery reignites the debate over Planet 9, a hidden giant possibly lurking in the solar system's far reaches. The theory began with the observation that several distant objects, like Sedna, have clustered, elongated orbits. It's as if a massive, unseen planet is shepherding them. Planet 9, if real, could be 5 to 10 times Earth's mass, orbiting hundreds of times farther from the Sun. Its gravity would shape the architecture of the outer solar system. Ammonite's orbit fits this pattern, consistent with a world flung outward by Planet 9's influence. Each new Sednoid strengthens the case, narrowing the search for this elusive planet. Finding Planet 9 would revolutionize our map of the solar system. Ammonite is a crucial clue, a gravitational fingerprint pointing to a hidden giant. The hunt for Planet 9 is now more urgent than ever. Planet 9 isn't the only explanation for Ammonite's strange orbit. The early solar system was a crowded place. Our sun likely formed in a cluster of stars. A passing star could have stirred up icy bodies, flinging some into distant eccentric orbits like Ammonites. Another theory suggests a lost planet, an ice giant ejected long ago, scattered objects outward before vanishing. Or perhaps thousands of smaller bodies in a dense primordial disk nudged objects like Ammonite over millions of years. Distinguishing between these theories requires finding more distant objects and mapping their orbits. The next great challenge is to see if their paths point to a single cause or a chaotic early history. Ammonite is just the beginning of this cosmic investigation. Ammonite's discovery forces us to rethink our solar system's story. The neat model of planets and belts is incomplete. There's a vast unexplored population with untold histories. Ammonite proves the early solar system was far more dynamic and violent than we imagined. Whether shaped by a hidden planet, a passing star, or a lost giant, its orbit reveals a history of upheaval. These distant worlds are tools for testing the laws of physics at the solar system's edge. Tracking their orbits could even hint at new physics beyond Newton and Einstein. Ammonite reminds us our solar system is still evolving, with mysteries waiting to be uncovered. Each discovery expands the boundaries of the unknown. The story of our cosmic neighborhood is richer and stranger than we ever dreamed. The discovery of Ammonite is just the beginning, a signpost to new frontiers. The search now turns to finding more Sednoids and distant wanderers. Upcoming observatories like the Vera C. Rubin Observatory will revolutionize this hunt, likely revealing hundreds of new objects. If their orbits cluster, Planet 9 becomes almost undeniable. If not, chaos or stellar encounters may be to blame. We are cosmic detectives, piecing together the solar system's ancient history. This quest speaks to our deepest curiosity, our drive to understand the universe. The story of Ammonite is a testament to human collaboration and persistence. It shows how, from our tiny blue dot, we can reach the solar system's edge. The darkness beyond the planets is filled with ancient fossils waiting to reveal our origins. With every discovery, we learn more about the universe and ourselves. The invitation is always there. Stay curious, keep asking, and never stop exploring.